Hi everyone, today we are going to see the illustration 3 of linear programming problems. Today I am going to explain about the maximization problem solved by corner point method. Okay, this is nothing but graphical method. So I am going to explain this how to solve this problem through graphical method. Okay, let's go into this problem. One kind of cake requires 200 grams of flour and 25 grams of fat. This is one kind of cake. Another kind of cake requires 100 grams of flour and 50 grams of fat. Find the maximum number of cakes that can be made from 5 kgs of flour and 1 kg of fat, assuming there is no shortage of other ingredients required for making cakes. Formulate LPP based on the information given and solve graphically. Here they have said about two kinds of cake. One kind of cake is above requires 200 grams of flour and 25 grams of flour and 25 grams of fat, and other kind of cake requires 100 grams of flour and 50 grams of fat, and for that the limitation is given. For flour the limitation is 5 kg and for fat the limitation is 1 kg. This is through these ingredients they are going to make the cakes. Two kinds of cakes. So the maximum number of cakes we have to find out. The number of cakes we have to find out from this problems. Previously we used to derive only the equations, constraint equations, and what that equation part only we have done. But here we are going to find the maximum number of cakes. Okay, the number of cakes we are going to find from here. Okay, let's go into the solution. First one. Let x and y be the number of cakes of first and second kinds of respectively. First step in linear programming is we are going to determine that we are going to decide our desired variables. What are all the variables? X and y here. The x be the first kind of cake and y be the second kind of cake. So our desirable variables are x and y. This is the first step. After first step, what is our second step? Is to find out the objective. What is the objective? The maximum number of cakes. So maximum means max. So maximum number of cakes we are going to make from two kinds. Okay, one is x, another one is y. So together how the maximum number of cakes we can make. Okay, that is our objective. So this is our objective function. Okay, this is done. And third part is our limitation, that is constraint. So we have to decide our constraints. What is the constraint involved in this linear programming problem? What are all the constraints? They have given 5 kgs of flour and 1 kg of fat. This is the constraint. Through the total number of cakes we can make from only 5 kgs of flour. So within 5 kgs of flour and within 1 kg of fat only we are going to make this two kinds of cake. So this is our limitation, that is our constraint. So this is our constraint. And what is our non-negative variables, non-negative factors? X and y, the number. Okay, this should be greater than or equal to 0. This is our non-negative factors. So like that we are going to derive the basic things. Okay. See our object. First thing is I just written the what are all the things given in the problem. Okay, the flour is for first kind of cake, the flour will be 200 grams and fat will be 25, and second cake, and what is the total number of flour availability and fat availability. Okay, so through that we are going to make our constraint equation. The flour for first cake is 200. So this is our x, this is our y. So 200x plus 100y is less than or equal to 5000 gram. So the 5 kg should be 5000 gram. So we converted the kg to gram because all things are in grams. So we just make this also in gram. Okay, like that fat, 25 grams of fat, 50 grams of fat. So the total limitation for the fat availability is 1000 grams. 1 kg 1000 gram. 1 kg is equal to 1000 gram. Okay. Now we are going to derive the constraint equation. 200x plus 100y. 200 gram for x and 100 gram for y. The total availability is 5000 gram only. So our constraint will be less than or equal to 5000. That the flour constraint is this much, and fat is our constraint. So 25 x plus 50 y less than or equal to 1000. Okay, just simplify it. I have written the simplified form, that 2x plus y less than or equal to 50. I just divided by 100. Okay, like that, just divide by 25 here, because for simplification purpose only, x plus 2y is less than or equal to 40. This is our second equation. So equation formed. And non-negative factor, I already said xy should be greater than or equal to 0. Okay, for this purpose, to solve this problem, we just converted this less than or equal to symbol to equal to. Okay, 2x plus y is equal to 50, x plus 2y is equal to 40. This is first equation, this is second equation. 2x plus y is equal to 50. This is our first equation. Okay, by taking this equation, if x is equal to 0, while taking this equation, in that equation, first we are substituting x is equal to 0. We are going to get the points for graph. Okay, to solve the graphical method, we need points. Okay, this is the graphical method part. Okay, here the graphical method part is starting. Okay, from here the graphical method is starting. We are substituting. If x is equal to 0 means 0 plus y is equal to 50. So y is equal to 50. So here the point will be x is equal to 0, y is equal to 50. So first point is over. Second, in the same equation, if y is equal to 0, 2x plus 0 is equal to 50, then x is equal to 25. So point will be 25 comma 0. This is our second point. Okay, from the first equation we derived 2 points. Okay, now next step, we are taking the second equation. From second equation, we are substituting the same method. Okay, if x is equal to 0 means y is equal to 20. In here, 0 plus 2y is equal to 40, y is equal to 20. So the point will be x is equal to 0, y is equal to 20. Again, if y is equal to 0 means x plus 2 into 0 is equal to 40. So x is equal to 40. So point will be x 40, y 0. So from equation 1, we got 2 points. From equation 2 also we got 2 points. Now we are having 4 points. Okay, now we are going to substitute these things in the graph. Okay, I will explain the graph. Here we are having 4 points, right? That is 0 comma 50, 0 comma 25 comma 0. This is from equation 1. From equation 2 we are having 2 points, that is 0 comma 20, 40 comma 0. This is from equation 2. So from this equation we are having 4 points. So from first we are going to match the first equation points. Okay, first one is 0, x is equal to 0, y is equal to 50. This is our x axis, y axis. Normally for a graph, what we have to do, like that we just put the graph, x axis, y axis, in that 10, 10 like that. Okay, 10, 20, 30, 40, 50 like that I made the points. Okay, from that points, x is equal to 0, y is equal to 50. That is our first point, right? So 50, this is our point. Okay, next one, 25 comma 0. So x is equal to 25. In between 20 and 30, 25 will be there, 25, and y is equal to 0. This is our y axis, y is equal to 0. So this is the point. So from for equation 1, the 2 points we matched in the graph. This is the thing. So here the first equation will be 2x plus y is equal to 50. For that we draw the line. Next, for second equation we have 2 points. From second equation we derived these 2 points, 0 comma 20, 40 comma 0. So 0 comma 20, x is equal to 0, then y is equal to 20. This is the first point. And 40 comma 0, x is equal to 40, y is equal to 0. So this is the point. So from second equation we draw the line. Okay, so our second equation is x plus 2y is equal to 40. Okay, this is also over. Okay, so we matched all the 4 points. Okay, and one more thing, in graphical method we have to remember this. Okay, for graphical method, if maximization function is there, our symbol will be less than or equal to. So if it is maximization or maximization function or less than or equal to means there is a limitation. Okay, it should be within, so it should be within the limit, that is towards the origin. It should be towards the origin. If it is minimization function means it is away from the origin. It is away from the origin, that is greater than or equal to means it should be away from the origin. Okay, so this is the maximization function, that is less than or equal to function will be there. So it should be towards the origin, it should be within the limit. So in that towards the origin the limit is there. So from that points we are going to find out the maximum number of cakes. So this is maximization function. So less than or equal to is there, so it should be less than or equal to, or maximization function means towards the origin. Okay, this is the rule. Okay, if it is greater than or equal to, or minimization means away from the origin, away from the origin, it will go out of the origin. Okay, so it is maximization function less than or equal to, so it should be near the origin. This is the area to find out the maximum number of cakes. Here we are having 4 boundaries. Okay, this one, this one, this one, this origin, and this one. Okay, for that we are going to give one name. Okay, for origin it is 0 or O, this one A, for this B, and for this C. Z, O, A, B, C. Okay, this is our points. Okay, this is our corner point. This is C. This is our corner point. These are our corner points. So 4 corner points method. So that's why this is called corner point method. So we are getting 4 corners. Okay, that is 0, A, B, C. Okay, we already know 0. This origin means 0, 0. A, here it is, we already matched. This is what? 0, 20. Okay, and we already this is 0, 0. This is 25, 25, 0, this man, and this one is 0, 50. This is our points we already matched. Okay, this is matched points. Okay, from that this is A point. For the A point the corresponding point is 0, 20. For B we don't know. Okay, let it be. For C it is 25, 0. So we know this is the point. This is X, this is Y, this is X, this is Y. For B we don't know the value for B. What is the corresponding corner points for B? We don't know. So for that we are going to find out the points. Okay, for that I am taking these to find the value of B by solving 2 equations. To find the value of B by solving the 2 equations, we can find out the value of B. So the first equation is 2x plus y is equal to 50, the x plus 2y is equal to 40. This is these 2 equations. By solving these 2 equations, okay, just multiply with the 2, 4x plus 2y is equal to 100 and x plus 2y is equal to 40. So subtracting 1 minus 2 we are getting x is equal to 20. Substitute x is equal to 20 in equation 2 or 1, any equation, we are getting the y point is equal to 10. Okay, so now we got the points. Oh, x is equal to 20, y is equal to 10. So the points for the point corresponding to B is 20, 10. This is our point for B. So now we got the value for B, that is 20, 10. So this is also done. So now we are going to substitute this because we are going to find maximum number of cakes. So we are going to substitute these things in this maximum function, the objective function. Okay, we are going to substitute these values in our objective function. This is our objective, we need to calculate the number of cakes. So for that we use the graphical method. Through that graphical method we got 4 corner points. From that corner points we are going to derive the maximum number of cakes. Okay, we are going to calculate the maximum number of cakes. Okay, the x plus y. So we are just substituting the x value and y value. So for corresponding to origin 0, 0, 0. Corresponding to a, that corner points 0, 20. So 0 plus 20, 20. For corner point B, 20, 10. So 20 plus 10, 30. For corner point C, 25, 0, 25 plus 0, 25. So among these points, which point is having the maximum number? That is B point. This is maximum number of cakes. So which point is having the maximum number? That is the point, is the Z is the maximum. So Z max is at point B, 20, 10. Here it is the thing. We can also, this is 20, 10, right? Here also we can able to, through graph also we can able to find out. But for a correct accurate value we solve that equation. In the graph itself it is showing 10, 20. So this is the maximum number of cakes. In this point we are getting the maximum number of cakes. So we are writing like that. X plus y is equal to 20 plus 10, which is equal to 30. The maximum number of cakes to be made is 30. So this is the maximum number of cakes we can make. And by making 20 numbers of, in that the corresponding value for x is 20, corresponding value for y is 10. So one kind. So this is the x means first kind of cake and y means second kind of cake. So then by making 20 numbers of first type and by making 10 numbers in second type, we are getting the maximum number of cake is 30. So this is the graphical method in linear programming model. So okay friends, thank you.